Welcome to Chapter 12, Part 2, K-nearest neighbors, KNN. In this section, we will explore the KNN method, its applications, and how it works. Let's get started. The K-nearest neighbors, KNN method is a memory-based reasoning technique that is simple yet effective. It is frequently used and produces highly accurate results, although it can be time-consuming and computationally expensive. KNN uses observations from the past that are most similar to new observations to classify or predict the target variable. It is known to be a very effective classifier but is less popular as a predictor. KNN does not assume an underlying distribution, making it a non-parametric method. Traditional methods require the predictor variables to be numerical, transforming categorical variables into numeric variables. KNN identifies a number of existing observations that are most similar to the new observation for classification. There are two main components: the similarity measure, typically standardized and Euclidean distance, and the number of nearest neighbors to consider, KEE. KNN searches the entire training data set for the most similar observation and provides a score for the new observation. Data partitioning is used to evaluate model performance and optimize complexity by experimenting with a range of values for K. Let's consider an example. A mortgage company is trying to determine whether a new applicant is likely to default on their home loan. The new applicant is 36 years old and has an annual income of $64,000. The mortgage company extracts information from 10 previous customers with similar income. The table shows the customer ID, income, age, and whether they defaulted on their loan. By comparing the new applicant's information with these past customers, we can use KNN to predict the likelihood of default. In this example, the three nearest data points closest to the new record are identified, so K equals 3. In this group of 3, only one customer defaulted, as indicated by the red dot. Therefore, the probability that the new applicant will default is 1/3 or 33%. Another example using JASP. The membership manager at 24/7's Fitness Center has collected data from 1,000 past open house attendees and 23 new open house attendees. They want to develop a model that identifies attendees who are likely to purchase a membership. Using past data, we can implement KNN for classification, compute and interpret performance measures and charts, and score the new records. For cross-validation, we will use the holdout method or the K-fold method to develop and evaluate the KNN classification model. Upload the GIM data file into JASP. Navigate to machine learning, then classification, then K-nearest neighbors. Drag the target variable and predictors to the appropriate box and select parameters as indicated in the screenshot. The analysis determined that the value K equals 9 yields the highest accuracy rate of 91%, with sensitivity, recall, at 90% and specificity, precision, at 91%. Interpret the chart using AUC, area under the curve, and score the target class. The AUC is very high at 95%, indicating that the KNN model performs extremely well in predicting gym enrollment. To add the predicted classes to the data, select the appropriate tick box and name the column Predicted Class. Thank you for your attention. This concludes our discussion on the K-nearest neighbors KNN method.